In this video, we're going to write the equation of a line into slope-intercept form. So before we can actually write an equation into slope-intercept form, we have to think about what slope-intercept form actually looks like. So remember when we graphed lines, our slope-intercept form was our y equals mx plus b form. So today our goal will be that we end in our slope-intercept form, where y is alone. So, now what we have to think about is how on earth we can convert an equation written in point-slope form into slope-intercept form. So let's look at an example. Say we had y minus 4 is equal to 3 times x plus 2. So this is written currently in point-slope form. And what we need to do is we need to rewrite it into slope-intercept form. So hopefully what your brain is already thinking is that, well, I could get rid of these parentheses if I distributed. So we would have y minus 4 is equal to 3x plus 6. And then hopefully what you're already thinking is that in slope-intercept form, y is alone. Here, y is not currently alone. The way to get y alone is to add 4 to each side. As we do that, these undo each other, and we're left with y is equal to, the 4 is going to combine with the 6 because they are like terms, so we'll have 3x plus 10. And then what we note here is that after we've distributed and added the 4 to each side, we are now ending in slope-intercept form. So what we're going to practice in this video is writing an equation of a line in slope-intercept form by rewriting it from point-slope form. So here our instructions say to write the equation in point-slope form to start. So notice here that we have a point and a slope. So here we have x1 comma y1 as our point, and we have m as our slope. So we start with point-slope form, which is y minus y1 equals m times x minus x1. So what we're going to do here is we're going to start by substituting in x1, y1, and m. So we take y minus our y coordinate, which is -1, is equal to -1/3 times x minus our x coordinate of -6. Now I notice here that because of those negative negatives, those subtractions of a negative number, we should use keep, change, change to make this a little easier to read. So we really have y plus 1 is equal to a -1/3 times x plus 6. So our first part is to write the equation into point-slope form. Then from here, we're going to continue rewriting, and we're going to convert our equation into slope-intercept form. So remember, our slope-intercept form is where we have y completely alone. So first we need to start by distributing. So here we get -1/3 x, and then I need to take -1/3 times my 6/1 as my second distribution. That becomes -6/3, which is -2. So as I distribute -1/3 to 6, I get plus a -2. And then my left-hand side is still the same. I still need to get y alone. So in my final step, I'm going to simply subtract 1 to undo this. And I end up with y is equal to -1/3 x minus 3 or plus a -3. So either way is fine. But note here, to get into slope-intercept form, we start in point-slope form, and then we convert it and rewrite it into slope-intercept form. So here our ultimate goal is to write the equation of a line into slope-intercept form, but notice that we have a slightly different representation. So here we're given 2 points, and we need to start by writing the equation into point-slope form. So we know that to do that we need a point, which we have 2 of, and we need our slope, which we find by using our slope equation of y2 minus y1 over x2 minus x1. So here I have point 1 and point 2. So I'm going to take y2 minus y1 over x2 minus x1. Then here I'm going to utilize keep, change, change. So I end up with 5 over 2. So my slope for this particular problem is 5 over 2. Then what I need to do is I need to write my equation into point slope form, and I can pick whichever point I like. So I'm going to pick this one to start. We're actually going to do it using both points, but I'm going to show you point 1 to start. So here we start off with y minus our y coordinate, which is negative 7, is equal to our slope of 5 over 2 times x minus our x coordinate of 2. So here I've now written it into point slope form, and now I'm going to convert it into slope intercept form by starting with the distribution. So I look here, I'm going to utilize keep, change, change to ensure that I don't make a mistake, and I'm going to distribute. So here we have 5 halves x plus, we then have, I'm just going to sketch it out here, 5 halves times negative 2 over 1. So that becomes negative 10 over 2 or negative 5. So we have 5 over 2x plus negative 5. And then on the left-hand side, I utilize keep, change, change, and I have y plus 7. So then from here, I know that my ultimate goal is to get y by itself so that it's in slope-intercept form. So I'm going to subtract 7 from each side. As I do that, these are gone, so I'm left with y on the left-hand side. And then here on the right, I have 5 halves x plus negative 12, or if you want to write it as y equals 5 halves x minus 12, those two are exactly the same thing. So by utilizing that first point, I was able to write my equation into slope-intercept form. Now we're going to do it a second time just to prove to you that it really doesn't matter which set of points we utilize. We're going to use that second point. So here I have y minus my y coordinate of negative 2 is equal to 5 halves times x minus my x coordinate of 4. Then my goal is to rewrite this into slope-intercept form. So I start by using the distributive property, and I'm going to utilize keep, change, change as well. So I end up with 5 halves x plus, well, this is 5 over 2 times negative 4 over 1. So that's negative 20 over 2, which is negative 10. Then I utilize keep, change, change on the left, so I have y plus 2. And then from here, I know that I need to get the y by itself, so I subtract 2 on each side. And again, I end up with y equals 5 halves x plus negative 12, or if you like the subtraction better, it can be either or, it doesn't matter. But what you should be noticing is that regardless of the point that we picked for point slope form, our slope-intercept forms end up to be exactly the same. So again, it doesn't matter which point we pick as long as we distribute and rewrite the equation for y alone correctly. So here again, we have the exact same instructions, but we have a different representation, so we can see that we have function form here. And our goal here is to, again, write this into point slope form and then convert that equation into slope-intercept form. So here we're going to start by interpreting the function notation. Remember, this is saying x is equal to negative 4. And then when x is equal to negative 4, y is equal to 37. So that's our first point of negative 4, comma, 37. And then the second one here is saying when x is equal to negative 1, y is equal to 10. So we have the point negative 1, comma 10. So here we now have 2 points, which will help us with the point part of point slope form. But we also need to find our slope. So I'm going to label this as x1, y1, x2, y2. Sorry, my handwriting got a bit bad there. It should be a 10. And then from here, we're going to find our slope. So remember, slope is y2, which is 10, minus y1, which I can see here is 37, over x2 minus x1. Well, Well, 10 minus 37 is a negative 27. And then here, negative 1 minus negative 4, I know is really negative 1 plus 4 because of keep, change, so that's 3. So we have a slope of negative 9 over 1, or negative 9. Then from here, we need to utilize a point and a slope to write our equation into point-slope form. So I'm going to use this second point here because it has smaller numbers, and I know that it ultimately doesn't matter which point I pick. So to write it into point-slope form, I do y minus my y-coordinate of 10 is equal to my slope of negative 9 times x minus my x-coordinate of negative 1. So then here I'm going to utilize keep, change. So I have y minus 10 is equal to negative 9 times x plus 1. So there's my point-slope form. Now I need to rewrite it into slope-intercept form. So I'm going to start by distributing the negative 9. So I have y minus 10 is equal to negative 9x plus a negative 9. Then I'm going to get the y alone by adding 10 to each side. So I ultimately find the slope-intercept form of y equals negative 9x plus 1. Lastly, we're going to end by looking at a word problem. So it says you plan to add Baldwin Lightstream TV to your home TV. While you do not know the cost, you know that Baldwin Lightstream charges a base fee for local channels and then a per channel fee for extra channels. Your friend Anna currently pays $68 for basic TV and 16 premium channels. So that's Anna's situation. While your friend James pays $92 for basic TV and 24 premium channels. So here I see two different situations, and I see two pairs of information. So I automatically know, since I see two pairs, that in this problem they are giving me 2 points. Now where this gets tricky is I need to create 2 points. I need to create 1 point to represent Anna. I'm going to do so in red. And 1 point to represent James, and I'm going to do that in blue. Where these get tricky is deciding what should be x and what should be y. So what I typically do is I look at the information I'm given, and a couple of key things that I can remember are that if we have anything with time, that will typically go in the x variable. Now I don't see anything with time here, so what I'm going to look at next is if I see anything with cost, that typically goes in the y variable. And as I look at this, what I notice is that Anna's cost is 68. So that 68 is going to go in the y variable because cost typically goes in y. So I have $68 as my cost for Anna, and then with that I get 16 premium channels. Those are the two things that I can see paired up. Now if I move on to James, I notice that James, I want to create that point in the exact same way. So my cost always goes in for y, so I have $92. And then I pay for 24 premium channels. So I've taken those two pairs of information and I've paired them up into points with cost as my y variable. Now from here, the next part says, what do x and y represent in the context of the problem? Well, if I look at my points, x here and here represents the number of premium channels I've added onto my service. And y represents my cost. So that's what happens in each of my points. Now from here I'm going to utilize this information and I'm going to write an equation into slope-intercept form. In order to do so, I need to start by finding my slope. So I'm going to take m and then I'm going to label these x1, y1, x2, y2. So I take 92 minus 68 divided by 24 minus 16. So I did y2 minus y1 over x2 minus x1. I then subtract 92 and 68 to get 24. 24 minus 16 is 8. Then if I divide that out, I get 3 over 1. Now, if I pause for a second and think about the units in my numerator, the units up here for 92 and 68 are dollars. So what my slope is really telling me is that my cost changes by $3 per one channel. So I can break that down. Now I'm going to write my equation into slope-intercept form, but to start, remember we always start our equations in point-slope form. So here I'm going to write my equation into point-slope form to start. So I have y minus, I need to pick a point. I'm going to pick this first point here since the numbers are a little smaller. So I have y minus my y coordinate of 68 is equal to my slope of 3 times x minus my x coordinate of 16. So then from here, I'm now going to rewrite it into slope-intercept form now that I have the point-slope form. So I'm going to start by utilizing the distributive property. So I have y minus 68 is equal to 3x minus 48. Then I need to get the y alone, so I add the 68 to each side, and I find the equation y equals 3x plus 20. So that's my equation for this situation, written in slope-intercept form. Now in parts D and E, I'm actually going to utilize this information to then make predictions. So here in part D, it says how much will it cost for basic TV and 9 extra channels. So I know from looking up above at part B that the number of premium channels is my x variable. So this is telling me that x is equal to 9. So I'm going to utilize my equation and say I need my cost, which remember I'm looking for my cost, which is y, is equal to 3 times my number of channels, which is x, plus 20. So here I would get 3 times 9 is 27, plus 20. So what that is telling me is it would cost $47 for 9 channels that are extra. Then if I look here in part E, this one is saying how many premium channels can you get for $53. So this is a different situation. Because they're giving me money, I know from up here that the cost is y. So I'm going to take this same equation here that I found in part C, and I'm going to substitute $53 in for y. So I have $53. I need to find x, my number of channels. So I rewrite this to solve for x. So I start by subtracting 20. So I have 33 is equal to 3x. Divide both sides by 3, and I find that x is equal to 11 channels. So if I want to have $53 exactly spent, I'm going to need to purchase 11 channels.